So now we're going to look at something called the limit comparison test, which is often easier to apply than the comparison test and can often be used in place of the ordinary comparison test, although not always. And here's how it goes. Suppose you have two series, the sum of an and the sum of bn, and they both have positive terms, and if it turns out that the limit as n tends to infinity of an divided by bn is some constant c, where c is a finite number greater than 0, then both series do the same thing. They either both converge or they both diverge. And so obviously if you have a series that is similar to another series that you know about, you calculate this limit, and if it's finite, then you can tell what the unknown series is going to do, whether it's going to converge or diverge. Note that c cannot be equal to 0 or infinity here. It must be some finite number greater than 0. So if you get a limit of 0 or infinity, you can't make any conclusion in this case. Let's test the following series, the sum of 1 over n squared minus 1. Now as n goes to infinity, the terms of this series are almost identical to those of the sum of 1 over n squared. So you expect this series to converge as the sum of 1 over n squared does. But if you try to apply the ordinary comparison test, 1 over n squared minus 1 is just slightly larger than 1 over n squared, so you can't make any conclusion from the previous comparison test. Well, let's try to apply our limit comparison test. The first thing is we want to make sure that the terms of our series are positive, and they are indeed. 1 over n squared minus 1 is bigger than 0 if n is bigger than or equal to 2. And we're going to try to compare it to the sum of 1 over n squared, which is convergent since it's a p-series with p equals 2. And so what we do is we calculate the limit as n goes to infinity of 1 over n squared minus 1 over 1 over n squared. This is just a rational function in n, so it's the limit as n goes to infinity of n squared over n squared minus 1. And we divide by the highest power of n in the denominator to get the limit as n tends to infinity of 1 over 1 minus 1 over n squared. And of course this is 1, and this is a finite number which is larger than 0, so we can now conclude that the sum of 1 over n squared minus 1 converges, as does the sum of 1 over n squared.